Hello, bachcho. Let's read the question. So the question says, a straight conductor carrying current I is equal to 5 ampere splits into identical semicircular arcs as shown in figure. What is the magnetic field at the center C of the resulting circular loop? So let us first revise the key concepts behind this question. So the key concepts behind this question are: first is the direction of magnetic field due to a arc is given by the right hand thumb rule. So let us write it here: right hand thumb rule. So right hand thumb rule says that if we take a small straight section of an arc and align our thumb of the right hand along with the current in that segment, then the curl of our fingers tell us the direction of magnetic field at any point around it. And the second key concept is the formula for magnetic field around an arc. So B magnetic field is given by mu naught I upon 2r into theta upon 2 pi. Here theta is the angle of the arc in terms of radians. Now keeping these two in mind, let us find uh, the solution. Now, before solution, in this particular question, we are given a case that the current splits into identical semicircular arcs. So, we can also revise another key concept from the current and electricity chapters, that if we have a net current I coming from here, and if we divide it into two parts which have same resistance, okay, which have same resistance, then the current in each arc can be given by I by 2 and I by 2. Hence, current is equally distributed. And how can we find that it is same resistance? Because if they are made with same material and are of same length, then resistance is given by rho into L by A. And if they are made with same material, then rho is equal a is cross section, and cross section is also kept equal, and length is also equal. Then there will be obviously uh, that current will be splitted into two equal parts. Now in this question, a similar case arises because the length of both of the sides is equal and of same material, and hence resistance will be equal. So current will be splitted into exactly two parts. So let us uh, try our solution part. So for solution part, we have I coming from here and a circular arc and another circular arc here. So this will be I by 2, and this current will also be I by 2, and the net current again will become I by I. Okay. Now we can find, let us take this arc as 1 and this arc as 2. Now let us find magnetic field at O due to arc 1. Let us name it as B1. It will be equal to mu naught into I. So current will be equal to I by 2, which is 2.5 ampere. 2.5 ampere mu naught I over 2 into R, the radius. So radius is not given to us. So we have to give the answer in terms of R. Let's suppose R is radius. So what can we write? Let's write it here R. So let's suppose R is the radius of the arc, and hence we can write here theta, which is pi in this case because it is a semicircular arc, and upon 2 pi obviously. So pi cancels each other out. This becomes mu naught into I by, let's suppose 2.5. Let's not put its value right now. Let's put it as I by 2 here. So it will be I by 2. So this will become mu naught I over 8r. So this is B1. Now let's find B2. So B2 will similarly be mu naught into I by 2 over 2r into pi over 2 pi, and pi cancels each other out, and this again becomes mu naught I upon 8r. So now we have to find the direction of each of them, because they on the basis of direction they are going to be added or subtracted at the point O. So for arc 1 we can find the direction by right hand thumb rule, and by right hand thumb rule it will be going into the plane of paper, so it will be given by cross for 1. And for R2 it can again be find out by right hand thumb rule. So by right hand thumb rule for R2 it is going outside the paper. So as they are both in opposite directions, so the net magnetic field B net will be given by B1 minus B2, and the direction will be then notified. So B1 minus B2, as we can see that B1 and B2 are equal, so this gives us 0. So there is no net magnetic field at the center. This is the final answer. That's why R was not given to us, because the final answer is not in terms of R. I hope you understood it well. Thank you.